welcome. The topic is classification versus clustering. Classification is it's in supervised learning where we have the labels and we classify the data according to the labels. Clustering is unsupervised. We don't have labels. We cluster it based on some similarity measures. Example, grouping of similar sizes of t-shirts. So we have like small, medium, large in the shops. So instead of customizing for each one, we have in groups like this. It's called as clustering. And target marketing and topic hierarchy, all these are examples of clustering. So some common ways to represent clusters: use the centroid method, center point of each cluster to represent the cluster itself. Compute the centroid, the center point of the cluster, and reiterate it and find the final centroid value. Using classification model, like here all ones are classified as 1, 2 as 2, 3 as 3. We have a labels here. So if x is less than or equal to 2, it's cluster 1. X is greater than 2 and y is greater than 1.5. So x is greater than 2 above this value and y is greater than 1.5. The value is cluster 2 and otherwise it is cluster 3. Use frequent values to represent the cluster. This method is for clustering of categorical data. Example, k-modes clustering. So main method, example like text clustering to identify the mode in the text, etc. Clusters of arbitrary shapes, hyperelliptical and hyperspherical clusters are easy to represent using their centroid. K-means clustering, it's a type of partitional clustering algorithm. Take the data points x1, x2 up to xn belongs to R in the example database I have given here. So what we do is here, step 1, randomly choose k data points. K is given, k number of clusters. So choose the k data point seeds to be initial centroids, cluster centers. So first we come up with the cluster centroids randomly. Assign each data point to the closest centroid. Find the distance from each data point to the centroids. For example, if k equal to 2 centroids we have assigned initially. Find the distance between each data point and each of the centroid value. Whichever is closer, mark that as one cluster. Recompute the centroids using the current cluster membership. So now we have 2 clusters. No, in that find the new centroid value. If convergence criterion is not met, go to step 2. Convergence is no or minimum reassignments of data points to different clusters, and no or minimum change of centroids, and minimum decrease in the sum of the squared errors, SSE. So here we have the data points here. Randomly we choose 2 centroid values, these plus values. Recompute the centroid values, assign the clusters like this. Recompute the centroids again, cluster assignment again. Do this till you reach the final state where the centroids and the data points do not change from one cluster to the another. The strength of k means it's easy to understand and to implement. Time complexity is order of tkn. N is the number of data points, k number of clusters, and t is the number of iterations. So weaknesses, it's applicable if the mean is defined for the categorical data k mode the centroid is represented. User v need to specify the value for k. Meaning the algorithm is sensitive to outliers. So outliers, the data points which are far away, very different from the other data points. Outliers could be errors in the data recording or some special data points. So like how to deal with outliers is remove the outlier points which are not at all close to the other data points, or perform random sampling. So we choose a very small subset of data points where there is more possibility that we don't choose the outlier. Limitations of k-means, it has different sizes, densities, non-globular shape. It has the problems when the data contains outliers. Thank you.